For this lesson, we're going to be looking at the slope of a line. So our learning goals are to understand what slope is and to calculate slope from both a graph and from a set of points. So slope is the measure of the steepness of a line or a line segment. So when I'm looking at a line segment, I want to look at how steep it is. So I could have a line segment like this, which would be steeper than a line segment like this. When we're thinking about slope, you want to think of the line like a hill. Think of how steep you would describe this hill to be. Think about how challenging it would be to ski down. This hill would be a lot easier to ski down than a hill that was this steep. The more challenging it would be to ski down, the steeper your hill. So when we want to define slope mathematically, and we want to mathematically talk about how steep a line segment is, we use this equation here. Slope is equal to rise over run. The rise is the vertical change between 2 points on the line. So this part right here. And the run is the horizontal change between 2 points on a line. So once we find our rise and once we find our run, we can use this formula right here to find the slope of the line. So let's do some practice. So we'll start with A, and we're going to graph both of these points here, and then we'll calculate the slope. So we want to graph the points 4, -1. So when we're plotting points, the first number is going to be along our x-axis. That's this axis here, our horizontal axis. Then we'll graph the second point, which is on our y-axis here. This point or coordinate is what is called an ordered pair. That ordered pair gives us a coordinate on this grid, and that will help us to find 2 points living on the line. So let's do an example. So we'll start by graphing 4, -1. So I look along my x-axis until I find 4. It's right here. And from 4, I'm going to go down 1 on the vertical axis. So that is 4, -1. And I'm going to label that with a nice A to remind myself that that is point A. And now I'll graph point B, 8, 4. So I'm going to find 8 on the x-axis, which is right here. And I'm going to go up 4. 1, 2, 3, 4. I should end up right here. And that's point B. I'm going to label it with a B. Now I'm just going to connect them in a straight line like that. So that is the line that we are looking at. We want to find the slope of this line. We want to determine how steep is this line segment right here. So to determine how steep it is, we have to find the rise and the run. So my slope is equal to the rise over the run. So let's find our rise. The rise is the vertical change. So I'm just going to look here to see the vertical change between A and B. If I count how many numbers are between A and B, we're going to count how far this is. So we have 1, 2, 3, 4, 5. My rise is 5. It is helpful to label it on the graph just to help you stay organized. So my rise is 5. I can put that in. And now my run. That's the horizontal change. So I'm just going to see how many spots are between A and B horizontally. So we have 1, 2, 3, 4, just like that. There we go. The last piece that we want to do is we want to look at our line and we want to just verify that our slope makes sense. And this is challenging to do when you first start, but as we practice, you'll get better and better at understanding if your answer makes sense. So I'm going to look here and notice how our line is going up to the right. This is a positive line. It's getting bigger. So it makes sense that our slope is positive. And it's relatively steep. Our slope is bigger than 1, so that also makes sense. But we just want to look at this and we'll compare it with the others that we will get in this example just to ensure that things are making sense and we haven't made any mistakes. Now you'll notice that I'm keeping the slope as a fraction. It's a good idea to keep your slope as a fraction whenever possible. So no decimals, definitely keep it as a fraction, reduce it as much as you can, but keep that fraction. So let's do another example. So for B, we're looking at the line segment from C at -3, 7 to D at 4, 3. So let's plot those points. We'll start with C. C is at -3, 7. So on the x-axis, I go to -3, which would be right here, and I'm going to go up 7 to here. Similarly, I'm going to label that with a C. Now let's plot point D. So we go to 4 on our horizontal axis, and then we go up 3. Now I'm just going to connect those points so we can look at our line. Now notice here how our line is going downwards to the right this time. This is in a different direction than the first line. This is an example of a negative slope because it's going downward. So we should expect that our value is going to be negative. So I'm going to find my rise and my run in order to find my slope. So I'm going to look at my rise. Again, that is the vertical change between my 2 points. So I have 1, 2, 3, 4. Now you'll notice here that to get from C to D, I'm going downwards. That means I have a negative rise because it's going downwards to get to my next point. So my rise is -4. Now for my run, I have 1, 2, 3, 4, 5, 6, 7. So my run is 7. Now, if we look here, 4 over 7, that's smaller than 5 over 4. So it makes sense that this line is not as steep as our first line. Let's try another one. So here we have E at 0, 4, and F at -4, -4. So I'm going to start by plotting point E. That was at 0, 1, 2, 3, 4. Again, just going to label it so it's clear which point is which. And then we have -4, -4. And I'm just going to label that one as well. And then we will connect them. Now you'll notice it's going up to the right? So my points are continuously getting bigger. So that means that this is a positive slope. So let's calculate our slope. So slope is equal to rise over run. So our rise, 1, 2, 3, 4, 5, 6, 7, 8. And then our run here, 1, 2, 3, 4. So rise is 8, run is 4. Now, we always want to reduce this as much as we can. So I can reduce this to 2. Now, this is the greatest value of slope we've had so far. So you notice here that it is much steeper than the other ones. That makes sense. So that means we've done something right. Our values are making sense with the diagram, and that's a really good thing. Okay, so our last part of this first example, D goes from point G 2 to 3, to H to -5. So let's plot those points. So point G is at 2, 3 right here. And H is at 2, -5. There we go, there's H. I'm just going to connect those. Now you'll notice this one looks a little bit different than the others, right? That's okay, we can still find the value. So we're going to find our slope, which is our rise over our run. Now, if I look at my rise, I have 1, 2, 3, 4, 5, 6, 7, 8. Now, there's no run. It doesn't go this way. It doesn't go this way. So, my run is just 0. Now, we always say we can't divide by 0. And if you try dividing by 0 in your calculator, you will get an error. It's because we can't divide by 0. And when we divide by 0, it means that something is what we call undefined. And we'll look at these vertical lines more later on. But these are what are called undefined lines. And the way to think about these is going back to our skiing example. When we're looking at these different lines, the larger the number of our slope, the steeper it is, the harder the hill would be to ski, the more challenging it would be. But when we're looking at a vertical line like this, it would be just a cliff straight up and down. It's impossible to ski. So that's why we call it undefined. So let's talk about our positive and negative slopes in a little bit more detail. So if a line segment has a positive slope, then it rises to the right, just like the pink line right here. Notice it increasing, rising towards the right. That is an example of a positive slope. So ones that look like this. Now, if a line segment has a negative slope, then it falls to the right. So it looks like this. Now, these are very, very important things to keep in mind, and the more we practice, you'll get really used to them, but we always want to think about whether or not our slope is positive or negative. Now, if a line segment has a slope of 0, then it is horizontal. It is a horizontal line. So, a slope of 0 would look like this. Back to our skiing example, that would be a skiing difficulty level of 0. Get cross-country skiing. So we don't have that steepness. It's a steepness of 0. It's completely flat. And then, just like we talked about before, if a line segment is vertical, then it has a slope that is undefined. And that is our straight up and down one. Okay, so that is finding our slopes using the graph. That's the first piece. But sometimes we don't always have the graph. And as we continue working with lines and working with slope, we want to get comfortable looking at lines on a graph, looking at just points, looking at tables of values. We'll look at a bunch of different ways to represent these. But because we don't always have a graph, we have to have other methods of finding our slope. So, a couple of definitions. So, this triangle shape is a delta, and it's a capital D in the Greek alphabet. And in math and science, it often represents change. So you may see this in science as well, and it's the change in a particular value. Now, we also want to look at, oh, sorry, we just need to change this to an A. We've changed it here. It should be an A on your page. Sorry about that. A is the letter we use to represent the slope. It just represents the constant variation. So it's just representing how fast something is changing or that level of steepness that we were looking at. So because of this, we can write a new expression for slope. So don't mind me just switching these to A's. They're already A's on your page, but it should say A, not M. So sorry about that. So when we write our other equation for slope, we want to look at the change in y, which is the same as our rise, right? How much did it change going up and down, divided by the change in our x. How much did it change left to right? So we can also write this in words. So I can say A is equal to the change in y divided by the change in x. Now, I can also write this as a formula. So my change in y can be represented by y2 minus y1, subtracting those y coordinates, and I'll show you how to do that, divided by x2 minus x1, the change in our x coordinates. So let's practice with this formula. So I'm going to find the slope of a line segment that goes from J, which is at 6,2, to K, which is at 10,5. So instead of graphing at this time, what I'm going to do is I'm going to use this formula. The first thing that you want to do is you want to label your points. It's a really good idea to label your points because points often get mixed up with this formula, so it's a good idea just to label them right away. So we have x1, y1, x2, y2. Now it doesn't matter which point you call point 1 and which point you call point 2. What matters is that my 1's are together, x1, y1, and my 2's are together, x2, y2. We can't mix and match. So once we have that, we can fill this into our equation. Now, it's very simple and straightforward to fill everything into the equation once we have it all labeled. So that is really important to ensure we label it all first. So y2 is 5, y1 is 2, x2 is 10, x1 is 6. So A, we'll simplify the numerator. 5 minus 2 is 3. And the denominator, 10 minus 6, is 4. So my slope would be 3 over 4. Now we'll try another one. So, for example B, we're going to find the slope from point L at 4, negative 7, to M, negative 2, negative 1. So we start by writing out our lovely slope formula. A equals y2 minus y1 all over x2 minus x1. So I'm going to label those points. We have x1, y1, x2, y2. Now remember, x always comes first. It's alphabetical when we have those coordinates together. So y2 is at negative 1 minus y1, negative 7. Now watch these double negatives here. It's really important because it's very easy to accidentally overlook those. So be very, very careful. Now x2, negative 2 minus 4. There we go. So negative 1 minus negative 7 is the same as negative 1 plus 7 all over negative 2 minus 4, which is negative 6. We'll simplify that numerator. Negative 1 plus 7 is 6 over negative 6, which simplifies to negative 1. And that's our final answer there. Just make sure you label those points. Makes a huge, huge difference and just reduces your chances of error. So let's try one more example. So a line segment has an endpoint of A, which is at 1, -3. And the slope of the line segment is -2/3. And we want to find two other possible points, B and C, that could also be on this line segment. So let's start by plotting point A. So it's at 1, -3, right here. And we want to find some other points on this line. Now, on this line, my slope is -2/3. So my slope was -2/3. Remember that we have rise over run. So -2 is our rise. This means we're going to go down 2. Then 3 is our run. So we're going to go right 3. So let's go from point A, and we're going to go down 2, and we're going to go right 1, 2, 3. And we're going to put a nice point here. And then we can just keep doing this. So we can go down 2, right 3, and these points are all going to be on the line segment with a slope of -2, 3. And if you go backwards and look at the slope using either the method from example 4 or the method from example 1, you'll notice that we get the same slope. So once you've completed this note, there is some homework for you to try. So go through it, try your best with the questions, and let me know if you have any questions with it.